All right, so we have been talking about limits, how to find them graphically, algebraically, with a table, all that good kind of stuff. So we are still working with limits, but this is going to be one of the applications of limits. I feel like this lesson also sometimes separates the men from the boys, and maybe you can decide whether or not calculus is really for you, because if the algebra that's in here freaks you out, we probably need to talk about your placement for next year. All right. So we're first going to start talking about a tangent line. Now, tangent lines you learned in Algebra 1, right? Not Algebra 1, I lied. In geometry is when you first learn about a tangent line. The way you learn a tangent line in geometry is related to a circle. And the definition you are given is that the tangent line intersects a circle at exactly one point. And that word exactly is so important for that. Totally true statement, works 100% for that. But then when you apply tangent lines to things that aren't circles, that word exactly gets a little fuzzy, and you have to have some explanations to go along with it. So this probably isn't the best definition of a tangent line, but it gives you an idea of what it is. It's a line that just touches a curve, which means when it touches it, that's where it's intersecting it, okay? So here we have, this is a tangent line, because you can see that it intersects it right here. It touches the curve. It's still an intersection because an intersection is something that they share. This is your tangent line. Okay. Here's where that it intersects at exactly one point kind of fails for you, is that if you have a curve that looks something like this, and then I draw in a tangent line, say, it's going to be tangent to the curve right there. So it intersects right there. Even though it just intersects one point right here, you can tell it clearly intersects your function at more than one point, right? So the better way, when we're actually applying this stuff and using it, when you're going to use it, what you're going to do a lot with in calculus with your graphs, is you're only going to be looking at restricted domains. So yes, overall, okay, it intersects at 2 points. It might intersect at an infinite amount of points, depending on what you're doing. But if you just restrict the domain to something that looks like this, then within that restricted domain, it only intersects it at 1 point. So a lot of times what we're looking at is just what happens in the neighborhood of this point, the stuff that's really, really close to it. All right, so this would still be considered a tangent line, even though it intersects the curve at more than 1 point. Does that make sense? And you'll just have some more specifics. It'll kind of be obvious. It's not even going to be anything you're going to have to guess at. Okay, so here's the problem with finding the slope of a tangent line, which is what we want. And because since this curve is not, well, it's a curve and it's not a line has a constant rate of change. In a curve, the rate of change changes, right? Things speed up and they slow down. And so when you want the slope of a curve, you always want the slope of a curve at a specific point. And so if I only have 1 point, I can't find the slope because I need 2 points to find the slope. Does that make sense? So we can approximate the slope of the line tangent to the function at x f of x, that's this point right here, x f of x. We use a nearby point, x plus h, f of x plus h. So here's what that means. Here's x, this is x plus h. So this could be 3 and this could be 5, so this will be x and then x plus 2, right? That's what the whole plus h means. We're just moving over a little bit. And if this is x, f of x is y. So whatever x is, I substitute it into my function, and then I get the y value. Whatever x plus h is, I substitute it into the function, I get my y value. That's all it is 2 points, x and y. So when you use those 2 points, you create a secant line. A secant line you also learned in geometry, and we've talked about both of these things actually a little bit, but they're definitely not brand new. Can't seem to draw a line. There we go. This is my secant line, and a secant line intersects at 2 points. So if I have 2 points, I can find the slope of a line. This is my secant line. So if I found the slope of the secant line, it would be close to the slope of my tangent line, but not really exactly what I want, right? But if I move this point closer, like if x gets smaller, if h gets smaller, then this point gets closer and closer to this point. As that happens, this line is going to start to tilt and become more and more like this line. Does that make sense? So I want h as close as it possibly can get to 0, so I actually have the tangent line, right? So the way that and if we just put in h equals 0, then I'm just going to have 0 over 0 because I have the same point. It doesn't make any sense. But we can find the limit. So the limit as h approaches 0 is going to then give us the actual slope of this line. And this is what this looks like. We've got the limit as h approaches 0 of f of x plus h minus f of x all over h. So let's look at where that came from. Let's talk about slope in general. You learned slope. It is delta y over delta x, the change in y over the change in x. The formula you usually see on formula charts for slope is y2 minus y1 over x2 minus x1. That should totally look familiar, right? If it doesn't, I would be really, really worried about you at this point. So we're using these 2 points over here to find the slope, right? So my y2 would be f of x plus h, minus y1, which would be f of x, over then x plus h minus x. You understand where those came from? Just from using those 2 points over there that are on my graph. So when I do this, to clean this up, well, I get x minus x, those zero out, so I'm just left with the h down here. So now this looks exactly like this, which is the slope when you take the limit. Okay, it's called the difference quotient. Difference because we're subtracting, quotient because it's a fraction, or because we're dividing. We good? So let's look at how we're going to use this. It says find the slope of the line tangent to the function at the given point. So again, the traditional way, I can't just find the slope with 1 point, but this is my x, then this is my y, but this makes this whole thing become negative 3 f of negative 3, right? Because it's x, comma, f of x, that's where you get the y from. And they just happen to give it to me. They don't give it to me every single time. So we're looking for the slope. So I'm going to say slope equals the limit as h approaches 0 of, okay, so it's f of x plus h, so f of negative 3 plus h minus f of negative 3 over h. Okay, everybody with me? Set of x plus h is negative 3 because that's my x. So now I'm going to actually evaluate the f of negative 3 plus h. So I'm going to take this, I'm going to substitute it into f of x. So this equals, oh, I didn't put 0 there. The limit as h approaches 0. And I can't stress to you enough how much your notation matters. You have to rewrite the limit. The great majority of you did that fine on the quiz. Some of you didn't. You just did a bunch of algebra and then said it at the end. That's a big time no-no. You won't get any points for that at all. Every single step has that limit attached to it. You can't have random stuff all over the place. So when I substitute this in here, negative 3 plus h goes into here. So this is going to be negative 3 plus h squared plus negative 3 plus h plus 1 minus, what is f of negative 3? 7, because it's that right there, all over h. Okay. So now I'm going to have to multiply out the numerator and clean all that up. So this is equal to the limit as h approaches 0 of, okay, so negative 3 plus h squared is 9 minus 6h plus h squared. And then when I add this, I'll have a negative 3 plus h. And then this plus 1 minus 7 is really just negative 6. I'll just go ahead and combine those two all over h. Everybody okay with where everything came from? You have to be able to square things like this quickly and efficiently. You trying to draw a box and do that mess at this point, that's not efficient at all. So limit as h approaches 0 of, all right, so I'm going to start to clean this up. And since it's a quadratic, I'm going to go ahead and put it in the right order. So I'm going to take that h squared, and I'm going to mark them out as I do them so I don't try and use them twice. I'll add 1h squared. Then I have a negative 6h and a positive h. So when I put those together, I get minus 5h. Then I have 9 minus 3 minus 6. That all zeroes out. So those are just gone. That's all I'm left with in the numerator, h in the denominator. Everybody good so far? Can I cancel these h's out right here? No. If you think yes, I'm worried about you. Limit as h approaches 0 of, but I can factor out an h in the numerator, h times h minus 5 over h. Now I can reduce these h's, and that leaves me with the limit as h approaches 0 of h minus 5. So now when I substitute in a 0, I won't get 0 over 0. When I substitute in 0 and I actually evaluate it, then I no longer write the limit, and my answer is negative 5. And what does negative 5 represent? Because if you can do all that, that's great, but you got to know what the heck the negative 5 even means. What is it? The slope. Sorry, but it's the slope of the line. The slope is negative 5. What questions do you have? We all good so far? Yes, ma'am. Yes, because when you are looking for the slope, it is, because the idea is that you want that h to get as close to 0 as possible, so the x's are the same. Yes, that's a good question. Anything else? Okay. All right, let's look at number 2. So I'm looking for the slope that's equal to the limit as h approaches 0 of, okay, so it's f of x plus h, so that's f of x is 2 plus h, minus f of x, oh, sorry, it is f of x, but what is x? 2, which is what I'm going to put there, all over h. So that is equal to the limit as h approaches 0 of, so f of 2 plus h is going to be 1 over 2 plus h minus 1 over 2 all over h. So this is equal to the limit as h approaches 0 of, in the numerator, I need a common denominator. My common denominator is going to be 2 times 2 plus h. That means my numerator is going to be 2 minus 2 plus h, parentheses matter, all over h. Got to be able to get a common denominator and not freak out about fractions. And the calculator not going to help you any with fractions here. So I'm going to clean up the numerator. The limit as h approaches 0 of, so 2 minus 2, so in the numerator of the numerator, the 2 minus 2 zeros out. What does that leave me for the numerator? Negative h over 2 times 2 plus h over h. Okay. So I have a fraction and a fraction, so I want to multiply by the reciprocal. This is equal to the limit as h approaches 0 of negative h over 2 times 2 plus h times, oh, why did I put a 5? I don't even know where that came from. Wow. My brain and my hand are not agreeing. This should be negative h in the numerator, not 5, times 1 over h. So then I can reduce these. That gives me the limit as h approaches 0 of negative 1 over 2 times 2 plus h. So now that I have it all simplified, I can actually evaluate the limit. And so that's going to equal a negative 1 over, when I substitute in 0, I'll get 4. And what does that negative 1/4 represent? Slope. That is the slope of the tangent line when x equals 2 of this curve. What questions do you have? Using the difference quotient. And this, again, once you talk about limits a little bit at the beginning of calculus, this is the next thing that you get into. So you're at least seeing it once now. Okay. So now, this goes on to say, if you know the slope of the tangent line at a given point, then you can write the equation of the tangent line using point-slope form. Point-slope form is the big boy and girl way to write equations of lines. Slope-intercept form, y equals mx plus b, is junk, unless you're given that form or you're given the slope and the intercept. Otherwise, it's point-slope form all the way. It's what you're expected to be rock stars at, and it does make your life a whole lot easier once you finally understand that much. Okay, so we want to find the equation of the tangent line, find the equation of the line tangent to the function at the given x value. All right, so in order to find the equation of a tangent line, or find the equation of a line, I need a point and I need a slope, right? I have an x value now. That's really all I have, but we'll figure out the rest as we go. So here's what we've got. We've got the slope. That's what we're going to find first. That's equal to the f of x plus h, so that's 1 plus h, minus f of 1 all over h. That's equal to, oh, what did I leave off? And I just made a big deal about it and I left it off. I wanted to see if, I said, pay attention to your limits, and then I left it off. It is the limit as h approaches 0. That is your slope. So that is equal to the limit as h approaches 0 of, all right, so when I substitute in the 1 plus h, I'm going to have 2 times 1 plus h squared plus 1 minus, and then f of 1 is going to be 2 times 1 squared plus 1 all over h. Any questions about where anything came from? Okay. So that is equal to the limit as h approaches 0 of, all right, so I'm going to, when I square this, and I'm going to square it and multiply by 2. So 1 squared is 1 times 2 is 2. Plus, then from this I'd get 2h times 2 will be 4h. Plus, and I'd have h squared times 2, 2h squared. Then I still have this plus 1, and then minus, well, 2 times 1 squared is 2, plus 1 is 3, all over h. Okay. Everybody good? All right, so that is equal to the limit as h approaches 0 of, all right, so when I start to clean this up, I've got 2h squared, and then 4h, then I have 2 plus 1 minus 3, that all zeroes out, and then I just have h in the denominator. So now I can say that is equal to the limit as h approaches 0. In the numerator, I can factor out an h. That leaves me with 2h plus 4 over h. What did I do? Oh, I could factor out the 2 also. Yes. You can. I'm not going to erase it. I don't really have to. I can. You probably would factor out the GCF. It works out either way because the h is the only thing we're going to be able to cancel, but absolutely I can do that. So 2 times h plus 2. Okay. So then I can cancel the h's. That's equal to the limit as h approaches 0 of 2 times h plus 2. All right. And now that I've done all that, I can evaluate it. So 0 plus 2 is 2 times 2 is 4. And what does this represent? The slope. So this is the slope. I'm not finished, though, because it asked me for the equation of the line tangent to it, so I need that. But I also need a point. So I need this, and then I need a point. I know that x is 1. What is the y value? You shouldn't have to calculate anything. Isn't it f of 1? Didn't we already find it? It's 3. So my ordered pair is 1, 3. My slope is 4. And so then I have y minus y1, which is 3, equals the slope times x minus x1, and you're done. Okay. What questions do you have? Anything? Okay, so we have found the slope given a point. We've found the slope given just an x value, which that process is pretty much the same. Then once we found the slope, we were able to find the equation of a line. So now we're going to find an equation for the slope. So it says we can also use the limit of the difference quotient to write an equation for the slope, not an equation for the line, an equation for the slope. So it says write an equation for the slope of the line tangent to the function at any point, then use the equation of the line to find the slope at x equals 4. Okay, so at any point means we don't have an x and a y value. So our slope will be equal to the limit as h approaches 0 of f of x plus h minus f of x over h. So we're still going to substitute it in like we have been. We just don't have a number for x. It's just x. So this is equal to the limit as h approaches 0 of, and I'm going to plug in x plus h into this right here. So this will give me x plus h squared minus 2 times x plus h minus 2, and then minus f of x, which is x squared minus 2x minus 2 all over h. So then this is equal to the limit as h approaches 0 of, all right, so when I square this is going to give me x squared plus 2xh plus h squared. When I distribute this, I get negative 2x minus 2h. And then I have minus 2, and I have minus x squared plus 2x plus 2 all over h. All right. Everybody good so far? Any questions about where anything came from? All right, so now we're going to clean it up. The limit as h approaches 0 of, all right, so I have x squared minus x squared, those zero out. Then I have 2xh. That looks like the only term I have that has an xh in it, so this is just 2xh. H squared, that's the only h squared that I have. Then I have minus 2x plus 2x, so those zero out. Then I have minus 2h, that's the only one. And then I have negative 2 plus 2 that zeroes out. So that's what I end up with. Okay. I'm going to factor out my GCF in the numerator. So this will equal the limit as h approaches 0 of h times 2x plus h minus 2 all over h. So then I can reduce those. That gives me the limit as h approaches 0 of 2x plus h minus 2. Everybody good at this point? So now that I've simplified it all down, now I can actually take the limit as h approaches 0, and when I substitute 0 in there, I end up with 2x minus 2. What does that represent? Slope. This is the slope, and this time it is the equation for the slope, since the slope changes, right? So I was asked to find, it says write an equation for the slope of the line tangent to the function at any point. That was the A part, so I did that. Any point. Any x you can substitute in, that's what you're going to get. We use the difference quotient to find it. This is also the derivative So derivatives, huge part of calculus. This is one way to find the derivative. The derivative of this function here gives me this equation, and that is the slope of the line tangent at any point there. Gives me the slope of the tangent line, or the equation of the tangent line. Then I have, says B, use the equation to find the slope of the graph at x equals 4. So when x equals 4, what's the slope? 6. And this is the B part. Questions? Okay. You will learn other ways to find derivatives, but the difference quotient is kind of where it all comes from. All right. So, again, we use the difference quotient. We found the slope, given a point or just an x value. Then once we found the slope, we also wrote the equation of the line tangent at that point. And then here, if you just put in the x and the h, you're going to get the equation for the slope, and then you can evaluate it at any point. Right? Any questions at all? All right. A lot of algebra in there, but I've been saying all year long, you got to be able to do that stuff quickly and efficiently and not lose yourself in there and not make ridiculous negative sign errors, or you'll never make it through any of it. The calculus is super easy. This is basic algebra, basic simple algebra that you just got to write out and not get sloppy with. Okay? All right. So